Hello everyone and welcome back to Complete Frontend. In this lecture, we are going to be talking about the number data type in JavaScript. I told you that we'll be diving deep into the data types and how they are stored in the memory location. But before we go there, I think we should first understand about the different kinds of data types and how they actually work under the hood, and then move to the understanding of how it is stored in the memory location. So in this lecture, we are going to be learning about the number data type in JavaScript. Numbers in JavaScript follow a pattern called as IEEE 754. So this is a standard, it's called as a standard for the number data types in JavaScript. You don't really need to worry too much about it, but you do need to know that, hey, this is the standard that JavaScript follows for numbers. So there are two kinds of numbers like we discussed. One is the normal double precision floating point numbers is what we call it. Double precision floating point number is nothing but a number that can also hold a decimal. Okay, it is that simple in simple terms. So essentially your number called 7.52, 1.06, all of these are double precision floating point numbers. Okay, what is an integer? You already know that it can be 1, 2, 3, 4. These are your integers. Okay, so these are the numbers that we are going to be talking about. The other thing is the big int. Big int, I think it deserves a lecture on its own. We will briefly touch upon that in one of our next lectures. Let's quickly start seeing what we can do with numbers now. So let me take something like let 1 billion, okay, is equal to 1 with 9 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? This is one way of writing numbers, but is this the only way? No. So it can be represented a bit differently as well with underscore, exactly like this. We can represent number like this with underscores as well, but it doesn't become a string or anything of the sort. So you can just say 1 billion or billion with underscore. It's gonna be the same itself. Okay, so let's quickly start running it and you will see that both are represented as numbers. So essentially this underscore is just for you to be able to read it better. Okay, so do we really use these many zeros when we are actually working with a number? We ideally don't. So the realistic way of representing a number would be something like, I would put something like 1e9. Okay, what is it? It just means 1 into 10 to the power of 9. That is what it means. Okay, so I think from the basic mathematical concepts that we have, you would probably already know this. So this is how you write it with an exponential, right? So now let's just quickly print it. It should also be the same. Okay, so I'll just press the up arrow mark to go to the command. So you can also use that on your computer. So as you can see, this is also the same. I can also write something like this, right? So this would also be the same. So 1 into 10 to the power of, so I can write 10 star star 9 over here. Okay, this would also result in the same thing. So if we just quickly print that out as well, you will see that it's going to be the same. So there are many ways you can represent numbers in JavaScript. So as you explore different ways of writing numbers, I think you will get a hang of it. So let's get to the next one. So how do you represent negative numbers? So using this exponential way, you can also represent negative numbers as well. So let's say negative billion, I'll say, okay, 1 star 1e minus 9. So it just means that it is the negative of whatever we wrote over here, right? Negative 1 billion. So let's just print that as well. So you'll be able to see that now it's a negative 1 billion. Okay, negative 1 minus 8. So there are also hex and octal numbers. You might have learned this while you were in school. So hex is nothing but representation of number with base 16, and octal numbers is nothing but with base 8. So let's see how we can represent a hex number. So for example, if there is a number called as hex number is equal to say 0xff, something like this, which is nothing but 255 in hexa. Okay, so we saw how a hexa number is represented. So this is nothing but 255 over here. Now let's try to look at something like retake. This can also be written as let hex num cap, I'll just call it. Okay, this can be written as 0x ff as well. This doesn't make any difference. Okay, now octal numbers is also something you would have seen, so I don't want to dive too much deep into it. Octal number, you can represent something like for example 0 O 377. I think this is 255 in octa. Okay, so you will not be using much of this while you're coding on a software product, unless you're working on something really different, then I don't think you will ever have to use this. So there is no need to particularly worry about this, but just know about this. So now let's say something like let num is equal to 255. Now what if I want to convert it to hexa number? So here you can write something like num dot toString. Okay, and you can pass the base into this. So if I pass a base of 16 into this, it's gonna give me the same ff over here. Okay, so it's the same ff over here, which is nothing but 255 in hexa, in hex. Okay, so here what is happening is nothing but in hex code, it is saying that in base 16 with 255, it's gonna be this. Similarly, you can also take a look for octal numbers. So you can just say dot toString and you can pass base 8. You can pass any other base number and you can check how that works. Okay, so this is nothing but what we saw earlier over here. This is the way of representing it. Okay, so 0 O 377. Okay, got it. So now that we have seen this, let's get into the more important concepts of numbers, which you'll probably be working more on a daily basis. Before we go there though, guys, if you're watching this lecture till here, please like and subscribe to this channel. It is very important for us to grow as well as a channel, so that I can reach to more people and make an impact in their life to teach them in depth about web development. So I'm just taking a moment over here to kindly request you to please like and subscribe and share this channel with your friends as well. Getting back, so let's look at rounding, how we can round some numbers. So you can take a look at a method called as math. Okay, and math.round is a method over there. So let's try to understand what this does. So I'm going to print a couple of this to show you the different scenarios, how numbers change based on this. So you might have heard about rounding, right? Rounding is nothing but asking to bring it to the closest whole number over there. So you might have seen when you go to buy something, they would say that, hey, it is 112 rupees. Then you would have asked the customer, the shopkeeper, that, hey, can you give me a discount of 2 rupees? Can you round it to 110, right? So the same way is what rounding is here as well. So if I print this now, it is nothing but, you see, it is just 3. What if I make it 3.4? It is still gonna be 3 only. What if I make it 3.5? That is 3.5. From 3.5 onwards, it's gonna be 4. Okay, so anything that I put from here is gonna be 4. Similarly for any other number as well. So this is what we call as rounding. Similarly, there is two other methods actually called as seal and floor. Okay, seal and floor. So why it's called as seal and floor? I hope this is obvious, but I'm just showing you this as well. This is your room, right? So what is this called as? Ceiling. And what is this part called as for your room? Floor. I hope this makes sense. So if you write something like 3.5, for that seal would be 4, for it floor would be 3. Got it? I hope that makes sense to you. So let's quickly take a look at that in the code as well. So if I just say math.seal of 3.1 even is gonna be what, guys? What is gonna be? I hope you made the right guess over here. It's gonna be 4. Like, similarly, if I make this floor over here, it's gonna be 3 only. Okay, so you will see that seal and floor, how they work. I hope that makes sense to you. It's pretty simple. The next one we will be looking at is about how do you multiply and divide numbers, and what methods can you use for that. For example, let's take, there is a number, let's take something with the decimal. Okay, so I'm just gonna say let num is equal to 1.45, some random number of things. Now what if I want to round this number just to 1.45? How can I do it? So by using math.round, let's try to do it. So I'm just gonna say console.log, and inside of here I'm gonna say math.round of, I want it to be 1.45 as the output. So what I would need to do over here is I would need to first multiply 1.45. I want 2 decimal rounding, right? So I'm going to multiply it by 100 first. Okay, and then I'm gonna again divide it by 100. Okay, I'll tell you why in just a second. I hope if you already know this, I hope this would be pretty simple. All I'm trying to do is to get, sorry about that. All I'm trying to do is to get it to be 1.45. So how did I do it? I first multiplied this by 100. So it was 145 for me. Then I said you round it. So whatever was above that, which is 35664, right? So 1.45. So it would be what? Essentially 145.3. Rounding it would be what? It would just be 145, and then I just divided it. So this is one way of doing it. This is not the most ideal way of doing it, by the way. So next one, there is a better way of doing it, like I said. And what is that? Let's take a look at that. So if I just say console.log and then math, I can just take num.to fixed, okay, and 2. Now it's just going to automatically round it to the 2 decimals. So it knows that I should just use the 2 precision point over here. So what it's going to do is it's going to say, hey, keep 2 decimals after this number and then just remove it. So as a proof, I know. So you can just use 4 over here and it would give you the 4 precision points. Okay. I hope this is a much easier way of doing it than how I just explained over here using math.round. This is not an ideal way of doing it, but who knows, you might need it in some calculation while you're working on it. Now, how are numbers handled when there are there is a very large number? Okay, let's take a look at that. So what if there is a number called large number, because it's a large number, right? So I'm going to say 1 to the power of 600. Okay, so will this be able to be stored in a number data type? Actually no, because this is a 64-bit number, so it is beyond that range, so it's not going to be able to store it. So what this is going to lead to is nothing but infinity actually. So if I just print this large number, it's just going to be infinite actually, because it's a too large of a number to store over there. It's a huge number, and I don't think you will ever need to deal with such numbers as well. Now I'll show you something very interesting. So what is 0.1 plus 0.2, guys? What is it going to be? It's going to be 0.3, right? So let's say sum is equal to 0.1 plus 0.2, which is going to be 0.3. Okay. Now I'm going to say console.log, I'm going to compare sum is equal to or is equal to is fine over here, 0.3. Okay. Now is it going to be the same? It should be the same, right? So this is nothing but the equality operator. We'll get to that in operator sections. Don't worry about it. But essentially I'm trying to compare is 0.1 plus 0.2 equal to 0.3. Essentially it's like asking is 0.3 equal to 0.3, right? So ideally what should be the answer for this? True, but it's false. Now I'll tell you why this is the case. Now let's actually print this sum over here. Okay, and let's see what the value comes up to. Now you see it is 0.30000000 whatever, and then 4, right? So at the end it is not an exact 0.3, so it is trying to compare this with exact 0.3, and obviously it's not going to be the same because there is a very small minute 0.04 extra over there, so it's not going to be the same. Now let's try to understand why this actually happens. Okay, so you know that numbers are stored in your memory location as a binary number. So computer only deals with binary, right? It cannot deal with any other format of numbers. I hope you already know this. So what computer tries to do when you say that, hey, I need to store a number. So Shrikant is asking me to store a number. So it's like, okay, what's the number? So 0.1. 0.1 is nothing but what, guys? 1 divided by 10, right? 1 divided by 10. Now in the decimal number system, it can store this because 1 divided by 10 is equal to 0.1. There is no more decimals over there. But now let's try to take a look at 1 divided by 3. What's it gonna be? It's gonna be 0.33333 and so on, right? It is never ending 0.3s. Got it? It's not a perfect division. It's always gonna be an unending number over here. So at one point it will have to stop it, right? So why am I talking about 0.3 over here and not 0.1? I'll tell you why. Because just like for the decimal number system, dividing anything by 10 is fine, right? For the binary number system, dividing anything by 2 will be fine. But dividing anything by any other base is going to lead to something like this, equivalent to this in binary. Getting me right? I'll tell you again if you didn't understand that. In the decimal number system, you can divide something by 10 and it will be a perfect cut. But if you divide anything other than 10, it's not going to be a perfect cut, or it has to be a multiple of 10, or it has to be something that leads to 10 as a multiple, right? So if I divide something by 3 or even 4, it's not going to be a perfect cut, right? But in the binary number system as well, if you divide something by 2, it can store it as perfect division. But if you cut it by 10, for example, then it's going to lead to this kind of decimals in binary equivalent. So it will store till an extent, but it's not going to hold the complete set of number over there. So that is leading to this imprecise number over here. Okay. So that is the reason why you will not get a perfect cut ever. It is mathematically not possible. Okay. So it's mathematically not possible to store it as a perfect cut over here. Now, if I want to actually compare this with 0.3, then we would need to do something like console.log, and in here I would need to say sum.toFigs of 1 decimal point is all I need, right? And then compare it with 0.3. Now this should give you true. Okay, this should give you true. So that is how you actually not lose precision or just not make mistakes like this, because you can end up actually with this kind of bugs and you would not be able to find why you have a bug in the system. So this is something we call a logical bug and not a syntax bug. So if you have a syntax bug, it would immediately show you that, hey, you have an error, I'm not able to build. But if you have a logical bug like this, it's very hard to debug. Okay. So there is one funny thing as well. Now let's take a very large number which is known to lose precision. So I'm taking this from one of the documents directly from the JavaScript. So this huge number over here. Now this is going to give you an output of actually completely different. It's actually rounding it off to the next one. So what's actually happening here is there are 64 bits for a number, right? So it actually stores in a 64-bit memory location. Okay. So as a 64-bit, 52 of them can be used to store digits, and that is not enough in this case. So what's going to happen is it's going to lose precision. Okay. So when you use or when you save such large numbers, if you really want to store it the right way, what you would need to do is use a begint, like I was telling you before, and then it would be able to keep the precision. So this lecture does not cover begint, so we will get to that in the next lecture. One other thing you would notice is that JavaScript has two zeros. There is one positive zero and there is one negative zero, and it doesn't mean that it is wrong in any way. It's just that when a variable is stored in JavaScript, it stores it with the numbers and the sign. So the 52 bits are used to store the number, and then there will be one bit that will be used dedicated to storing the sign. So in this case, both 0 and negative 0, because technically it's not wrong, because you have especially told that it's a negative 0, it's going to store that separately. So how you can actually imagine this is that, see, you have a memory location over here, and say this is your 64-bit tray. Okay, there is one bit where you would store the sign. Okay, so here plus or negative will be stored. In 52 bits, your number will be stored. I'll tell you what this is for in the later part of the lecture. So this 52 bits will store the number, which will be 0, and you gave specifically negative here, so it's going to store that separately. So technically it's not wrong. JavaScript is exactly doing what you asked it to do. Now, I briefly touched upon nan in one of the previous lectures where I was actually introducing you to data types. So nan is a special type. So you can check if something is a nan by doing is nan. So you can do something like console.log is nan, not a number of nan, let's say. So this is a default nan. This is going to give you true. Let's check also something like is nan of something like 10, 19. Okay, fine. I made a typo, but it's still a number. And then let's get into something like is nan of something like Shrikant. Okay. Now, can you guess the output of all these three? So for the first one, it's going to be true because is not a number, not a number. Absolutely, it's not a number, so it's true. Is not a number for 19? No, number is 19 is actually a number. So is it a not a number? No, it's not a number, it's actually a number. So this is false. Is not a number of Shrikant? Yes, it's not a number, it's a string, so it's true. Okay. There is one other funny thing in JavaScript. Even I don't know why this is the case, but if you just compare nan to an, it's going to give you false. Even though it's the same thing, it's going to give you false. So why this has happened? It's saying that nan is not going to be equal to anything at all. There must be a reason why the JavaScript developers initially put that in such a way. We don't need to worry about that on a daily basis as being a developer. So you need to know that there is a function called as nan, which is a safety check that you can use before actually directly using something as a number. There was one time when I was looking at LensCart and it was giving me price is equal to undefined or null or something like that. So to avoid such scenarios, you can use this and default it to something like 0 or something like that. Okay. There is a concept of parse int associated with the numbers as well. So if there is a string called as say 100, I'm going to assign this as a string. Now if I say console.log of parse int of say this string, it can actually convert this to a number. Okay. So now it will actually give you a number type. It did not give you a string type. Now what if I give you something like pixel over here? It will still be able to do it. It will be able to extract the number out of it. Okay. So you can actually parse the number out of a string by using this. In case if your backend is giving something like a string, but you want just the number part of it, you can use this. Similarly, you can do this with float as well by using something called as parse float. And in here, say 100.5 or something like this, right? So this will give you the float of this. Okay. So I hope this was easy. One other thing we need to talk about is there is something called as math.random. Now what this does is it generates a random number between 0 and 1. So it cannot randomly give you any number you want. It's going to give you a number between 0 and 1 with the decimals. So you see here it generated a decimal number between 0 and 1. So how do you actually generate a number out of this? You can multiply it with any multiplier that you want and it will give you a random number to deal with. Now of course you can again use math.round to actually get a whole number out of this. So if you're generating something like a random number game or something like that, you can use this math.round to deal with it. So I have a small assignment for you. I want you to create a piece of software that can generate random numbers, whole random numbers. So by using the math.round and math.seal and floor as well, generate a random number generator function and then comment it out in the comments below, and I'll be very happy to see that you have completed this assignment. One other thing guys, if you're actually watching this lecture till the end, it means that you are on the right path to get to that FANG job that you always wanted. I'll tell you why. While I was learning JavaScript, I used to watch every lecture till the end. I used to make notes and understand them and actually do the assignments and try them out myself. If you're also doing that, there is no doubt that you will also get to your goal. But if you haven't watched till then I don't know. So I hope you enjoyed this lecture and I'll see you in the next one.